Okay guys, let's go ahead and get started. So we're talking about radicals. We're going to start at the beginning and talk about what is a radical, how we can identify radicals, how we can simplify them, and how we can add and subtract. This is what we're going over today. Alright, let's start off with the very, very basics. This symbol right here, most people say that's a square root, but this is actually the symbol for a radical. Now, a radical can take on different meanings depending on what number is in this spot right here. We call that your index. Most of the time we don't see a number in that spot, but there is actually a number. What number is it?
2.
It's a 2, and what does that tell you? It's a, not squaring, it's a square root. So there's a big difference between squaring and a square root, okay? I'm actually going to do a quick little side on this. You don't have to write down what I'm about to do. Let's see if this will work. No, it's not.
Come on, board.
Oh boy, dude, you have one job, board. Oh. Okay, here we go. If I gave you a number 5 and I said, hey, I want you to square 5, most of you would say, what? What do you do there? 5 times 5. I want you to think about this more literally. If I'm going to square 5, I'm going to go and I'm going to build a square. It's like Build-A-Bear, but cooler, okay? But all the sides are 5. What is the area of that square?
5 times 5.
Which is 20. Length times width is 5 times 5, so 25. So 5 squared is 25. Now, if we were to do that backwards, okay? What if I said, hey, I've got this square. What does it mean if it's a square, by the way?
All sides are the same.
All the sides are the same, and I say, hey, and the area of this square is 64. What is the side length?
8.
4. Now, 4 would be if we're doing like a cube. We'll get to that in a second. This one would be 8. Because I have to think what number multiplies by itself to give you 64, and you would say 8. What you guys just did right there is you did a square root. The square root of 64 is 8. Okay? Now, we're going to take it to the next dimension. We're going to go to a cube. Okay? So how do you do that? Well, I'm not the best artist, but let's test my skills. So I start with this square, and then we're now going to go to the next dimension. And it's not perfect, but that's supposed to be a cube, right? All the sides are the same. Now, if I said all the sides are 5, and I said, now instead of what is the area, I would say, what is the volume? How much stuff fits inside this box? What would you do with the 5? Cube it. 5 times 5 times 5. You build a cube out of 5, and what is the volume? 125. So 5 cubed, if I build a cube out of 5, it gives me a volume of 125. Well, let's change that a little bit now. I'm going to draw another cube here. Maybe this one will be a little bit better. And that's, okay, it's not great, but it's okay. Let's say I have this cube here, and I'm told that the volume is 81. Nope, that won't work.
That's not cube.
27, that's what I was going for. Let's say that the volume here is 27. What would the sides be so that you could figure out the side length? So they're all the same, and when you multiply it gives you 27. What you're doing here, this is a cube root. Look on your chart, what number multiplies by itself 3 times to give you 27? You would say 3. So the cube root of 27 is 3. Does that give you a quick understanding of like the difference between a square and a square root, a cube and a cube root?
What does this 4 look like?
Now let's go to the next dimension of
Is another
time. No.
dimension? Like,
Good luck with that. That's beyond my drawing skills. Okay, so now what we're going to do is go back to is going to determine whether we're doing a square root, a cube root, or a fourth root. Now I don't have a good visual for a fourth root, but you're just saying what number multiplies by itself 4 times to give you 64. Now look on your chart. What number multiplies by itself twice to give you 81? 9. What number multiplies by itself 3 times to give you 27?
3.
When you did the fourth root, did we have anything for 64?
No.
The cube root of 64 is 4, the square root of 64 is 8, but do we have anything for fourth roots?
No.
So in that case, we would just leave it alone.
It's not.
We'll talk about ways we can simplify that here in a minute. Okay? Now here's more of your vocab. So the index is this number out in front. It tells you whether you're going to square root, a cube root, or a fourth root. This is your radical sign. And the number underneath the radical sign, that is called your radicand. Okay? It's important to remember that because sometimes people are like, radicals are hard, I can't do this. And I say, you radicand do this. Just hang in there. Alright. Now, I'm actually busting out your guys' sticks of destiny. I put everyone's name on a stick, and this gives me an easy way of calling on people without people saying, you're biased, you chose me because I was looking at my phone. I say, yeah, put your phone away. Okay. Maybe. There we go. I want to have you guys do some help with me here in a second. Now, the easiest skill that you have to have with this is all you have to say is there a radical or is there not? Or building off that, could you write a radical? So your level 1 skill here, it's going to show you an expression, and if it has a radical that can't be simplified, then you say it's a radical. If it's not a radical, then you write it, it's irrational. Okay, now don't overthink this. Square root of 3x, does this have a radical sign? So what do you write? This is a radical. Yeah. Oh, sorry, this wasn't in your notes, so just write it somewhere. Or just pay attention and memorize it in your brain. Now, cube root of 4x, I can't simplify that. Is there a radical symbol there?
Yeah.
So we write radical. There you go. Okay, help me out on this one, Skylar. Square root of 25 is 5. I simplify that. Is there a radical on it now? So what do we write instead? There we go, irrational. What do you guys think of x squared? Is there a square root sign with it? Could I rewrite it so there's a square root? Nope, so I'm going to put that's rational. And this is like how you're going to get at least a level 1. Is just if you see a radical sign, it's radical. If you can simplify it or there's no radical sign, then it's rational. Now, last year in secondary 2, you learned you could rewrite a square root as x to the 1/2 power. It's a fraction exponent. Yeah. It's like this index of 2, it actually became the denominator in the exponent. The same is true with a 3. The cube root is the same as a 1/3 power. So sometimes these problems, it will give it to you in a couple of different forms. It could give it as a radical or as a rational exponent. And what you need to do is figure out, can I rewrite this as a radical? Okay? So, for example, x to the 2/3. That 3 is going to become the index of a cube root. So I'll write the cube root of x squared. Do you see how I converted that from this form into a radical? Now it has a radical sign, so how do we label it? Radical.
So is it not rational before? Even though it doesn't have a radical?
So yeah, looking at this, we would basically, some people might look at that and say, oh, it's a fraction, it's rational. But I can rewrite it as a radical. So if you can rewrite it as a radical, you want to write it as radical. What about this one? X to the 3/5. What can we do with that 5? Do you remember what the vocab word is? It's going to become our index. Good job. So we'll have the fifth root of x to the third. That's a 3 there. And I can't simplify that, so what do I write there? Radical. Now, let me show you when this actually does work out. I have the square root of x to the 6th. So help me on this one, Melissa. If I were to rewrite this, how could I change that from a square root? How would I rewrite this as an exponent that's a fraction?
X to the, 6 over 2.
Yeah, and what does 6 over 2 simplify to? This is 3. Hey, it just became a 3. Is there any square roots here? Anything that could be a square root? Nope, so we're just going to call that rational. Okay, let's do that same thing with here. 4th root of x to the 6th, that 4 is going to come right here. So I have x to the 6 over 4. Can we reduce that 6 over 4? Yeah, well, what will it become? It'll be 3 over 2, okay? But did it simplify all the way? That 2 there, that can still be written as a square root of x cubed. So if there's still a denominator here, then I can still write it as a radical, which makes it radical. Yeah, see, I grew up with Teenage Mutant Ninja Turtles, and anytime something cool happened, they would say, radical. Yeah. So that's what comes to my mind. Radical, bro. Alright. So do you get the basics of this? If there's a square root, it's radical. Or if it has a radical sign, it's radical. If it has a fraction in the exponent that you can't simplify, you can rewrite it as a radical. If not, it's rational. You guys can all do that, right? That's the first part of your quiz. The second part is going to be simplifying, okay? Simplifying, this is a skill you learned last year, and we're just going to build off of it, because you probably just did square roots. We're going to look at cube roots, we're going to look at variables, we're going to simplify those. Now, some of these are pretty easy that you did with your perfect squares chart. For example, square root of 25, what is that? We should know that. What about square root of 100? What about the square root of 225? That's actually beyond our chart. That one is 15. Good job. But what about the square root of 20?
It's like 4.4.
Something between 4 and 5, right? But is it a perfect number, a whole number? No.
Radical.
This is a radical. Yes. But what I want to do is I want to simplify that. Do you guys remember how to simplify those?
You do 5 times 4 underneath the radical sign.
Uh-huh.
And then you take the 4 out. It's like 2 times 2.
Do you guys remember doing this?
Yes.
What we're doing is well, of course you do,
And
because
then
you were the
take
one
it out.
telling us, but I was asking the others here. So this is prime factorization, 2 times 2 times 5. And then you're looking for buddies here, or pairs. And then only 1 comes out, so the square root of 20 is 2 square roots of 5. Okay, give me raise a hand. How many of you remember doing this last year? Okay, awesome. Did your teachers, when they taught it, did they use any fun analogies or anything? We're going to make a fun analogy out of it, because we might as well. So what we're going to do, guys, when we're simplifying these radicals, I like to think of it as a jailbreak scenario, okay? So, yeah, exactly. The radical is going to be your jail. And you're stuck in jail. And no one wants to be stuck in jail, so what are they going to try to do?
Break out.
Break out. Now, the way this jail is built is the only way you can break out is if you have a buddy. But that buddy has to be the same as you. You got to be the same height, the same weight, because then you can help each other get through the same spots, if that makes sense. Okay? But not both of you can ever escape. Only one can escape. The other one dies. So, yeah, one has to sacrifice themselves for the other one, okay? So let me show you what I mean by this, okay? Square root of 8. We're going to look at square root of 8 by breaking it down. What numbers multiply to give you 8? 2 and 4, and then I can keep breaking down 4 as 2 and 2. So I like to circle them when I'm at a prime number, a number that can't be broken down anymore. And then I can rewrite the square root of 8 as 2 times 2 times 2. Now, remember our jail, we want to get out of jail, you need a buddy, which is a group of 2. So these 2's, they're like, you know what? We're done with this place. We're going to break out. So one night when the guards are asleep, they go through and they break out, except one of them didn't make it. Poor guy.
They also didn't buddy with the other guy.
The other guy was like, I'm not going to risk it. I'll stay put. Say hi to my wife and kids. Okay. So here's the 2. Here's the square root, and then here's. So the 2 that made it out is here. The other 2 died, and that 2 goes down.
See, it has to be changed how you write your 2's. Like, some of them are written with a curl, and some of them are written normally.
I didn't even notice that. Interesting. Alright, so square root of 8 simplifies to 2 squared to 2. Let's keep trying this. We already did 20, right? But let's show it again using our buddy system here. 20 breaks down to 5 and 4. And 4 breaks down to 2 and 2. Now someone was like, hey, but 20, what if I put 2 and 10? Well, then you'd break down 10 to 5 and 2. You'll get the same numbers here. So it doesn't matter how you break it down, as long as you break it down all the way to the end.
Break it down to
To the prime numbers. We call that prime factorization. So now the 2's can buddy up again. Okay? Caleb, what's going to happen to these 2's?
One of them's gonna die and the other one's gonna escape.
Well, one is going to escape, is that what you said?
Yeah.
Yeah, there we go. So one of the 2's makes it out, and they're a free man now. And the 5 is just stuck in there, because he needs a buddy. Okay, I want you guys to break down the square root of 40 and the square root of 21. See if you can do the next 2 on your own. Over with the buddy, just don't escape or die.
What if they can't escape? No one can escape the jail of 21.
Alright, let's get some help here calling on Skylar. How'd you break down 40? Yep. You keep breaking down 4? What about 10? So then I'm going to rewrite this as a square root of, I have 3 2's and a 5. Is that what you guys got as well? Cool, keep going with this, Skylar. Can we have any jailbreaks here? Who? What happens to them? They don't stay.
They die.
They're not there anymore. So, this one will stay, though. I don't know if that's the one we're talking about. But we got the 2 that escaped. Who is still inside this jail? And those we're just going to multiply them together, so this is 2 square roots of 10. Do you guys agree with Skylar 2 square roots of 10?
Yeah.
Awesome. Okay, this skill of simplifying, it shows up when you do adding, it shows up when you do multiplying, it shows up when you do solving. It's a pretty easy skill, but you need to know how to do it, or else you're not going to be able to do the other skills, okay? Make sure you got it. Now 21 is 3 and 7.
No one can ever get out.
Do they have any buddies here?
They're so smart.
No.
Self-discipline.
Can't help each other. They're just stuck in there until their time is served. All right. Let's go and do the same thing now, but can we do this with variables? It's the same idea, but I'm going to show you a shortcut, okay? So let's just break this down. What does x squared mean? How many x's are in there? Do you have buddies? Yeah, so I'm going to take my buddies. What happens to them, Jade? Yeah, so sometimes people draw him still in there. No, he dies, he's gone. So this just becomes x. Who's left in the jail? Everybody got out, or at least they tried to. One made it, one did. Okay, let's try that now with x to the fourth. How many is that going to be? How many x's is that, guys? So we've got 1, 2, 3, 4. Which now we can have 2 escape parties, right?
Yeah.
These 2 are going to try to escape. These 2 are going to try to escape. One makes it, one dies. One makes it, one dies. So who's still left over?
Yes.
Now we got to be careful on how we write that. So we got an x that made it out, another x that made it out. So we have x times x, which is x squared. It's not 2x, that would be if you added them, but x squared is when you times it. Okay, now I could do the same thing with x to the 8th. I could do the same thing with x to the 10th. I don't want to write out 8 x's and do 4 groups and 4 whatever. Are you noticing a pattern here? What is the square root of x squared? X to the 1. What is the square root of x to the 4th? What's the pattern here?
It's a half.
It's half, because how many groups will you have? Half of that, and one makes it, one doesn't, right? So, if you remember what we were saying about square roots, is it's right, you could rewrite it as making that 2 become the denominator here. So this would be x to the 8 divided by 2, which is
4.
Isn't that a little bit easier than writing out 8 of them and 4 escape buddies and 4 make it, 4 don't? I guess. It's not as entertaining of a story, right?
Not as like a height,
Yeah. So, Angela, what about x to the 10th? If I'm doing the square root of that, how could I rewrite this as an exponent that's a fraction? What does that simplify to? All right, good job. So we simplified numbers, we simplified variables. Let's do some practice of simplifying together, okay? All right, so I've got 45 n squared. So with the 45, we're going to break it down, look for buddies. With the n squared, break it down, look for buddies, and then we'll do both of them. So Brian, I think we have 3 Brians in this class, and I think they're all young. So Caleb, will you break down 45 for me?
Yeah.
What's 45?
5 and 9.
And break down 9.
3 and 3.
So this is the square root of 3 times 3 times 5. And n squared I want to write as 2n's. Okay, Caleb, who can escape?
Just one of the 3's and one of the n's.
Good, so 1 makes it, 1 dies. 1 makes it, 1 dies. So who's on the outside now?
3 n's.
And who's still on the inside?
5.
That is correct. Nice job, Caleb. You guys have any questions on how we did that? Okay, let's go to the next one. Antonio, help me out with this one. How would you simplify this?
6 times 6.
Yeah. Now, can I stop there? Do I need to keep breaking down 6?
Yeah.
So you could, and you get 2 and 3 and 2 and 3. But if you get buddies right here, you can stop right there. And that just makes it so you don't have to write as much. And then, so let's do this. So